Tonight's special guest speaker, Dr. Jim Sullivan, is the Executive Director of Florida Atlantic University's Harbor Branch Oceanographic Institute. Dr. Sullivan is an oceanographer with a broad research background focused primarily on phytoplankton and harmful algal blooms. He's particularly interested in improving our understanding of harmful algal blooms and communicating that information with policymakers and the public, which is part of what he's going to do tonight. Dr. Sullivan holds a master's degree and a PhD from the University of Rhode Island's Graduate School of Oceanography. He has over 60 peer-reviewed publications and several patents to his credit, and currently he serves on Florida's Blue-Green Algae Task Force and is council chair of the Florida Institute of Oceanography. Tonight, Dr. Sullivan will tell us about past, current, and future research being carried out by scientists at Harbor Branch Oceanographic Institute. Please help me welcome to the stage Dr. Jim Sullivan.
All right, I am really happy to be here. Did anyone, I have to ask this right away, I gave a very similar lecture about 3 weeks ago at Harbor Branch. Was anyone at it? All right, this is going to look very familiar to you. But thanks for coming. For the rest of you, hopefully you'll learn something about Harbor Branch and a little bit about me and what all our scientists do at the Institute. You know, and I want to start off with our little tagline here in the corner of this opening slide, Ocean Science for a Better World. We truly do believe this. I mean, it is the heart of what we do as a research institute as part of Florida Atlantic University. We want to do applied research that benefits all of you. So, I was appointed director of Harbor Branch in 2018, so I am finishing up my 7th year as executive director. In 2018, Harbor Branch was going through a lot of transition. I had a lot of turnover in leadership and was maybe not, performing quite as well as it could have. And at that time, I was asked to come up with some priorities of what I wanted to do to get the Institute going. So my priorities in 2019, way back when I didn't know anything, was to expand collaborations within FAU. We're part of the university. We used to be independent, but now we're part of FAU. Expand community outreach and education, just like I'm doing right now, talking to all of you. Expand corporate and government research collaborations. Increase philanthropic support. You heard Zach talk about it. This is, all of our institutes depend on you for support. But the overarching goal, and this was incredibly important to FAU, is to increase the research enterprise. And when I say that, what that really means is just bring in more funding to the university and the institute. Grow what we do in research. The reason for this was back in 2000, actually, it was probably more like 2015 or 16 when John Kelly was our president. The strategic goal that he set was to become what's called an R1 level research university. To attain that, you have to do a certain level of research dollars, obviously, have to have a certain number of postdocs, and you have to have a certain number of PhDs in your training programs. FAU at that time was what was called an R2, a second level. It was not the top level research university designation you can get in the United States. So to cut to the chase right away, if you look at this plot, this is Harbor Branch research funding over from 2016 to last fiscal year. The big arrow is when I took over, essentially. And if you would take that back about 3 or 4 years before that, we had a flat research income of around $9 to $10 million. Since then, we've done quite well. We're on a nice trajectory going up. Research goes up and down depending on funding, success, and all that. But we've at least doubled our research enterprise, which is great. Some years we triple it. And this has been true of FAU in total as well. If you look at this on the right-hand side, this is the research across the entire university. The number, it's got a slope. If you look at how it's rising, almost exactly the same as Harbor Branch is doing across the university. And they say the research expenditures are $104 million in 2024. Expenditures are all the money you spend, but the actual money you're bringing in is 75.9 or 76 million. Well, if you look at what we brought in, we're close to 27 million. So we're over a third of all the research dollars that come into FAU, which is a large university, is done right at Harbor Branch up the road from here. And FAU will be designated an R1 level research university this year. Thank you. Thank you very much. You know, and I said this last time I gave this talk. I'd like to take credit for it. It has very little to do with me. It has to do with the great work that our scientists and staff do. They work really hard, really, really hard. So how did we get there? So that's like the answer to the story, but now the details. How did Harbor Branch achieve its research enterprise? We do research in 4 main areas: ocean health and human health, aquaculture innovation, food security, marine ecosystem conservation, and technological innovation and national defense. And I'm going to go through all 4 of these and give you some examples. I can't do everything, we'd be here for hours, of what we've currently been doing. So in ocean health and human health, this is some examples of research activities that we're doing. We actually, unlike a lot of oceanographic institutes, we do drug discovery. So we are actually trying to farm the oceans for novel therapies for cancer, antibiotics, whatever we can develop. And these are called natural products, just like they look good. They go down to the rainforests and look for these unique molecules they can find in plants and animals. And if you're successful, you can actually create new drugs that can be quite useful to our health. We have a Center of Excellence in Biomedical and Marine Biotechnology, mostly focused around cancer cell research and finding therapies for some of the more difficult cancers that we have. And as part of that, we do a lot of ocean exploration and biomedical technology. To look at marine natural products, you have to collect samples from the ocean. We don't go in and destroy reefs and take them apart. We take little tiny samples and look for chemicals. We do not kill animals to do it, but then bring them back and see if there are any unique compounds in there that we can synthesize and use. We do a lot in marine ecosystem health, obviously, looking at pollution, climate change, ocean acidification, diseases that we see spreading in our ecosystems. Ecosystem toxicology, you heard I'm interested in harmful algal blooms. That's what I study. A lot of the toxins in the environment are created by algae, and they have a lot of effects on wildlife and us. And because of this, we started a comprehensive harmful algal bloom research to look at that. So for the biomedical research, this program continues its research into finding a lot of new drugs. They have had some good back-to-back banks where they're going out into some of our reefs in the Gulf of Mexico, or I guess the Gulf of America it is now. And to get samples to bring them back and analyze them. And Florida, the Department of Health of Florida, just gave them 2 grants. One of them's is still active, and one just ended. And it's looking at some different compounds to fight cancers against pancreatic, colon, and lung cancers. Pancreatic cancer is very difficult to cure, so we do need drug therapies for that. And also triple-negative breast cancer. And that one, I guess, is having some success. They are finding some compounds that are worthy of going into further trials. So harmful algal bloom research, I talked about health, toxicology. It's what I'm trained in. It's what I study. The reason I wanted this to be a focus of what Harbor Branch does is because of this map. If you look at this map, and it's very simple, this is not everything that occurs in the state of Florida, but these are all the primary algal bloom issues that we have in the state almost every year. We have Oreo umbra, which is up in the northern part of the Indian River Lagoon. Mostly it's what they call brown tide, makes the water look like coffee. It's responsible for killing most of the seagrass up there. Pyrodinium is a bioluminescent dinoflagellate. If you go up to Merritt Island in the summertime and you take a canoe out, it'll glow. Has anyone here done that? Yeah. So, however, it's also highly toxic, so don't drink the water. Pseudonychia is actually an emerging issue. It's a huge problem on the west coast of the United States. Causes a lot of neurotoxic shellfish poisoning in sea lions, humans, seabirds. But we're starting to see it in the lagoon a lot. Thankfully, it's only mildly toxic. Hopefully that won't change, but we're watching it closely. Microcystis, the big green things you see across the whole state, and then specifically around Lake Okeechobee, that's blue-green algae. That's the common one that causes microcystin poisoning. It's a liver toxin. It's something that is pretty much, if there is a freshwater lake and it's got any kind of pollution in it, microcystis is going to be in it. And Lake Okeechobee is just an endemic problem right now with this. Corynea also creates a neurotoxin called brevetoxin. That's what, when you hear Florida red tide, that's what it is. So it's Corynea brevis. Mostly a problem on the west coast of Florida, but we get it over here occasionally too. And then there's various cyanobacteria blooms that are sometimes toxic, sometimes not. Ciguatera, we get down in the Keys, that's fish poisoning. Some people here have probably had it if you eat a lot of, right? If you eat a lot of fish down south, you can get it. That's also a dinoflagellate or an algae that causes it. And now we have this spinning fish disease. Has anyone heard about that? We think we know what it might be, but no one has definitively proved it. But we have scientists at Harbor Branch who are actually working on that right now. But given all this, it's pretty important that we understand what's going on. This is a consistent problem in Florida. When I took over, I created the Florida Center for Coastal and Human Health in 2018. And it was the first year I started. And what this center was, I established it to get all our scientists trying to work together and other colleagues from other places to foster comprehensive research looking at all the different effects these harmful algal blooms can have and how their toxins get into the food chain and what they potentially do to us. And hopefully get that information out to stakeholders like you, and more importantly, the people in the state who can regulate and hopefully help clean up this problem. And just here's a couple examples of just some recent stuff that was done this year. We consider all this center research. Brian LaPointe, Rachel Bruton, Malcolm McFarland are all research professors at Harbor Branch. They recently published a paper in Harmful Algae looking at all the cyanobacteria or the microcystis blooms essentially within the entire Lake Okeechobee waterway, from the lake to both coasts, and looking what its dynamics are like. We work with the Indian River Lagoon National Estuary Program. We are funded by them and the EPA. They're actually an EPA organization to do continual monitoring of toxic harmful blooms in the Indian River Lagoon. So we're always out there, specifically the southern part of the lagoon. And another thing that we just got from the Florida Department of Environmental Management, how many people saw the sargassum blooms we've had over the last couple of years? That can be, on the beaches, a nuisance algal bloom. Can be harmful. It actually has arsenic in it. In heavy concentrations, it may do damage. But DEM gave us money to understand the impacts of this up and down the Florida coast as well. So this is only a small part of what we do, but we're highly active in trying to understand this. In aquaculture innovation and food security, a lot of people don't realize that Harbor Branch has one of the largest aquaculture parks in the state. So we have a very large area. We do a lot of type of aquaculture, and I'll hit on some of it right now. So we do species cultivation research. You have to hybridize animals and figure out if they'll grow in captivity. We work on their nutrition, how to keep them healthy. You don't want them to get disease. They're a crop. You're essentially growing them for food. So you have to do all that. And we work with seaweed, shellfish, shrimp, anything that potentially can become a food crop. We work on a lot of technology development. We're our research institute, so that's the biggest thing we do. AI systems control, automation, working on new feed formulations. Now, a lot of things that aquaculture does, a lot of people don't realize. They think aquaculture, they think food. They think, oh, I eat salmon that was grown in a farm. Well, all the restoration efforts that you're going to see that occur, like restoring coral reefs, or restoring seagrass, or restoring conch, or fish stocks, that has to be done using aquaculture. You have to grow these animals somewhere and then put them back out in nature. So to grow the stock that you need to restore, you're dependent on aquaculture to actually help you do that. So that's a big part of what we do too, working on all these different conservation and restoration aquaculture efforts. And because of this, we have what's called the Center of Marine and Warmwater Aquaculture. which is supported by the USDA. And the reason for this, and the reason the USDA is supporting this research at Harbor Branch, 50% of the seafood that you currently eat comes from aquaculture, whether you know it or not. The reason for that is that natural fishery production, what we can exploit out of the ocean, is tapped out. We're not going to get any more. It has gone up and plateaued, and if anything, it's going to start going down as we start depleting fisheries. So you can't get more seafood from the ocean. It's at its peak. So if you want more seafood, and we're going to depend on it in the future for a growing population, it's going to come from aquaculture. But the USA is not that good at aquaculture. Less than 1% of aquaculture food is produced in the United States. Today, it's a $15 billion trade deficit. It's a lot of money. And if you look at this graph on the upper right, where is all this aquaculture food coming from? It's coming from Asian countries. We're literally a little blip on this graph. The United States understands that this is an issue. We got to invest in it, and we have to create this industry. We have to support that industry. So we are now working with a collaborative research with USDA-ARS, to advance how we can do this sustainable domestic supply of marine waterborne fish and sea stock. If you're going to grow fish in captivity in aquaculture for food, you need to provide them with the baby fish, the eggs, the brood stock that they can actually grow. So we do the research that essentially can supply these manufacturers of aquaculture food. And we've done quite well. We've got over $10 million over the last 5 years from the USDA, helping them cooperatively try to increase the USA's business in this. We do a lot of technology research development. If you watch this video here, that's actually a drone that just took off. A lot of fish we do is done in ponds. It's not done in recirculating, and it's not done in the open ocean. And the farmer has to go out and sample all these ponds to make sure there's enough oxygen for the fish, there's enough food, whatever it is. That's really labor intensive. But we have now developed, and there's a couple grants over there you can see, an automated AI system that'll go up, it'll take off, it'll fly over the ponds, you can map out where you want it to go, and it'll actually go down right into the water, and it's got a sensor on it, and it will take those measurements and immediately send them back to the farmer. So they don't have to be running around doing this. They can get this data, and this robot will essentially do it for them. And then it'll take off, do it again. But they've done quite well doing this, but this is the kind of technology we work with to, again, support the growth of this industry in the country. As I said, a lot of our restoration efforts have to be done through aquaculture. It's a critically important thing. Two big things we've done recently. We got a $2.8 million gift for establishing a queen conch farm in Grand Bahama. I don't know how many people eat conch fritters and conch or like it. Conch has been overfished, as you would guess. And in the Bahamas, it's a sustenance fishery. These people depend on this, to survive. And we have overfished it, essentially. And, in the Florida Keys, I don't think you see conch all that much anymore either. We can actually, again, grow little baby conch and put them and then reseed them back out into the environment so we can get these fisheries going again. Same thing with seagrass. The lagoon has lost a large percentage of its seagrass. Why is seagrass important? Well, it's a natural habitat for fisheries, all kind of animals. It's also a food source for some of our larger animals like manatees. A couple of years ago, you all heard about manatees starving if you're a local Floridian. That's because there just was there was very little seagrass out there for them to eat. Well, if we're going to eventually replant this stuff and get the lagoon back to where it needs to be after we clean up the water, we're going to have the seagrass stock to actually plant, and we're working on that as well. For this Queen Conch Lab, this work is being done by Dr. Megan Davis, and she has done amazing. She has both these mobile conch hatcheries and regular conch hatcheries she can set up in a country. And she is putting these hatcheries All those black dots you see on that map, those are current projects where hatcheries are going out. We're building these things at Harbor Branch, and they're being sent to these Caribbean countries. And she goes down there and trains the local people how to grow the conch and replant it and put it back out. And she's got more going on. Her goal is to get a conch farm in every single Caribbean country, and she's well on her way to doing it. Seagrass nursery expansion, we grow seagrass. We do a lot of research in seagrass, and that's understanding how they grow, creating hybrids, which species can we get to grow well when we get to the point of restoration. So we have really started to expand our seagrass nursery to do all this kind of research and to grow this stuff up. We've got a lot of partners in this right now. FPL gave us a large donation. The NEP did as well. Florida Fish and Wildlife are now a partner. And our own Harbor Branch Oceanographic Institute Foundation gave us $1 million towards working on expansion of this. And this is going on right now. And we also work with FOA, Brevard, different groups. There's a lot of people working on this and doing the research. So when we can actually really start planting out the lagoon, we'll be ready to do it. Marine ecosystem conservation. Now this is what you'd expect Harbor Branch does. We're an Oceanographic Institute. We study everything from virus to whales. You know, if it's an animal swimming around in the, or even a virus swimming around in the ocean, there's probably someone studying it. And this would be what traditionally an Oceanographic Institute does. But some of the research activities we concentrate on, we do a lot of marine mammal research and conservation, stranding, rescue, pathology, population ecology. If there's a dolphin stranding, a whale stranding, usually a manatee stranding as well, we'll help FWC. But there's almost always a Harbor Branch employee there to help the animal. We have a marine veterinarian. If the animal is distressed and cannot be saved or rehabilitated, they will humanely euthanize it for the sake of the animal. We do a lot of wildlife population dynamics, looking at sharks, rays, fish, turtles, pretty much everything that's out there. As you would expect, we do a lot of coral reef ecology and health research, seagrass ecology and health. I mean, we're studying this stuff. We want to work on it. We do have the Indian River Lagoon Observatory Network, and of course, I already mentioned it, we do a lot about harmful algal bloom dynamics in the state and across the world, actually. So just a few to mention some of the work that is being done in this area. Marine predators and prey. Matt Ajamian is a professor at Harbor Branch. He got a very prestigious NSF Career Award. They give you $1 million to let you concentrate on a really important part of your research. He's working on predator-prey interactions between when we put out shellfish farms or try to like conch, put out fisheries and want to restore something, which animals are going over there and eating them before they have a chance to grow? You know, so he looks at how can we understand what they're doing and how can we improve our restoration efforts through this research. Adia Chavez-Fanegra is another Harbor Branch faculty member. She's a joint appointment with the Wilkes Honors College of FAU. She got a career award, and these are not that easy to get. So it shows you the quality of research that people are doing at Harbor Branch. She's working on looking at sponge-dominated coral reefs for the benefit of biomedical research and restoration efforts. A lot of the natural products we can get from the ocean that can be used for creating new drugs, they actually come from sponges, not coral. So it's critical to understand them and what the diversity is like. We also have a coral reef conservation research lab, the Coral and Molecular Ecology Lab. This is run by Dr. Josh Voss. This has been a lab that's been going on for quite a while. Different people have been parts of this. Josh is currently leading it. They've done 46 research expeditions over 15 years, and I mean, this is where you have to get on a boat and go way out in the ocean, put on dive tanks, and go down to the reefs. They look a lot at some of these deeper, unknown mesophotic coral reef ecosystems, so these aren't the ones that you can go and snorkel on. You actually have to go down deep. I mean, they're down there quite a ways. But they're always trying to look at where we can find new coral reefs, how are the species changing, and what are the fisheries like around them. And a big thing they do is give their data and recommendations to a lot of our reserved areas. A lot of coral reefs are protected now, and we want to keep them that way, but they help the government. It's like, here's the condition of this. This is, you can't allow fishing here, you can't do this. So they do the kind of research that the government uses to determine if they need to make it a reserve underwater, so to preserve it. And they train, Josh probably trains more graduate students than anyone else at Harbor Branch. A lot of people are interested in this research, so we get a lot of young scientists out of this program. Marine mammals and sea turtles, as I told you, we do a lot of that. This is mostly by our veterinarian, Dr. Annie Page. She just found a new species of bacteria in some of these pygmy and dwarf sperm whales. She's also working with the Dominican government to better understand the Caribbean sperm whale. She is literally in Dominica, as I speak, on a boat studying whales. She just got there yesterday, and I know she's out there today. And she also works a lot with sea turtles. So she also does research tracking leatherback sea turtles' movement and ecology, where they nest, how they feed. But this is all important if we want to understand these animals and preserve them or conserve them. I told you we run the Indian River Lagoon Observatory Network. Does anyone here ever check this or look for data when they're out fishing? Oh yeah, a couple people. This is used a lot by scientists too to understand the health of the lagoon or just the environmental conditions out there. It's pretty much 24/7 real-time data that's available. It's supported by DEP and a few other organizations. But it's a network that spans from the St. Lucie estuary, pretty much we're up north of Brevard now. So it's a pretty large observatory real-time network. And it looks at how the water quality is doing and how algal blooms and all that. What is it like on a day-to-day basis? And it gives us these long-term data sets that we can understand, is the lagoon getting cleaner? Is the lagoon getting dirtier? So we can start to look at what those long-term trends are as we try to improve water quality in the lagoon. Last thing I'm going to talk about as far as our research side goes is the technological innovation and national defense work we do. Harbor Branch was founded on technological innovation. The deep diving submarines, the Sea Link, was developed at Harbor Branch. It was a passion of Ed Link, one of our founders. He created the Link Trainer, which was a World War II flight trainer for all our pilots. So he was an engineer, he was fascinated with the ocean, and he hooked up with Seward Johnson, who also loved the ocean, and they created Harbor Branch over 50 years ago. But almost all of it around this engineering and technology. And to this day, this is a major thing that we do. Some examples of stuff we do in this research focus area: a lot of ocean engineering technology development, new novel instruments and sensors. We do a lot of Department of Defense collaborations. I literally cannot talk about a lot of it, just because you can't. We do a lot of, I'll actually give you a taste of what we do, but I cannot give you any details. Ocean optics and underwater imaging, we do satellite remote sensing, new sensors. We actually have one of only 4 in the country renewable energy centers. This is marine renewable energy, SNEMREC. And I started in 2021 another center at Harbor Branch called the Center for Marine Applied Technology and Engineering. So, as I said, I started this in 2021. It's run by another HBOI professor, Dr. Mike Twardowski. And basically, we have a lot of engineers and scientists, and we want to create new instruments, or we're working with a partner who needs something, and our engineers and scientists can figure it out. And we'll come up with a concept or a theory, or someone will tell us, hey, can you do this? And we'll work on it. We'll do some benchtop testing. We'll then do some very controlled environmental testing as part of it. We'll start to build prototype assembly and staging, and we have a full machine shop. CNC, 3D printing, we can do all of this at Harbor Branch, so we do. We used to have large boats, and we could repair anything. We'll start taking it out and working with devices, and we do real-world testing, and we'll actually transition to our partners. Generally, it's the Navy, because we're an Oceanographic Institute. And this is, the way we do this kind of research to transition sensors to help defense-related industries. One of the big things we do, and remember I talked about Merritt Island This is an overhead shot of the bioluminescence up there. Someone's in a little motorized kayak. It's actually part of our group working on bioluminescence. We have a very large grant from the Office of Naval Research to look at bioluminescence and persistent maritime surveillance. An extremely large amount of money over the last 5 years, over $22 million from the Navy to work on this. Why do you think bioluminescence would be important to the Navy? You said submarine. I can't say it, but when you have stealthy things in the water and they glow when they go through the water, they're not so stealthy. And now with really high resolution satellites and drones, it's a vulnerability to things that drive underwater. But you can see dramatically why there. So the goal of this project for the Navy is to better understand and characterize bioluminescent emissions. You know, what and who are these animals that are getting off this light, and then how it affects what we call proxy targets, things that drive underwater. And we look at, the emitting groups. We understand them. We do research on them. We develop instruments. We look at how, when something goes through the water, how it gives off light. But then we look at how do we see that from the air? How do we see it from a satellite? So there's a lot in this, and creating instruments to measure it. And some of the project elements, $22 million is a lot of money. You got to go somewhere. We've worked on a new state-of-the-art instrument for the Navy to assess the amount of bioluminescence in the ocean. Now, they have to operate all over the world. They used to have an instrument called the HIDEX, which they deployed all over the world to measure it to know how much bioluminescence is in the ocean. That was actually developed, oddly enough, at Harbor Branch back in the 80s, way before my time. We're now developing the next generation instrument for them called the Codex, and it's a bathyphotometer. In other words, it measures bioluminescence. We're working on acoustic systems that look at some of the animals that create it. Fluid dynamics modeling is you want to see how the disturbance of the water through a body moving through the water makes them give off light, because they get disturbed and they give off light, like when you're paddling your canoe through the water. Imaging systems that can see it. What does it take to do it? Looking at identifying different animals by how they give off light. And that last thing is radiative transfer. That it just means, can we model when we see light underwater, how far it can be seen up into the sky by a satellite or a drone? So it's a really complex and very cool project. That's not the only thing we do. We actually work with a lot of DoD corporate partners. We've had a long-standing relationship with Raytheon. We developed an anti-submarine technology. It was a device that would send a sonar array and tracker, essentially, for submarines out of the back of the littoral combat ships. And then we built a smaller one for the fast attack vessels. Raytheon came. We demonstrated it for the Navy at Harbor Branch. The Navy ultimately decided not to go with the version that was developed by Raytheon. They're using a European device, but we built basically the entire mechanical structure of this for the Navy. We work with L3Harris. They're right up the road in Palm Bay. They work on our campus a lot. Our scientists jointly work with them and do collaborative research projects. We work with a small startup up in Melbourne, Mainstream Engineering, working on their dual integrated cyclone. It's a way of looking at the seawater chest in a destroyer or some of these large surface vessels to keep the water clean as it goes through. And we work with this company called C Corp, and they work with us a lot and this is the Naval Undersea Warfare Center up in Newport, and they're up in the Rhode Island area, specifically on some of this ONR research we do. But we're always looking for partners that we can work with to do some of this defense work. I talked about the marine renewable energy we do. We have the Southeast National Marine Renewable Energy Center on the Harbor Branch campus. In the recent, I would say 10 years, there's been quite a bit of money done in marine renewables, a lot with wind. But this is underwater turbines, so things we can put out in the Gulf Stream. Gulf Stream's a constant current. It's always running. It's very strong. It's 24/7. It's not like wind, which does go on and off. And we just got a large $4 million grant from the Department of Energy to start trying to prototype and get closer to putting this out as a deployable system. I think they're going to do it off Lake Worth. That's where you can get really close to the Gulf Stream off the Florida coast. All underwater. It's built so it's not going to harm whales or dolphins. It's not a huge turbine with open blades. It's going to cut things apart. But this research is very active and ongoing. We do a lot of single instrument development, as I said. This is a real-time sediment nutrient fluxes. How many people have heard of muck or legacy nutrients in the sediment? This is usually a big thing in Florida. It's really hard to measure. They say, oh, there's 50 years of nutrients stored in the bottom of Lake O. We got to burn out or clean out. Well, you got to measure that somehow, and you got to see what that flux is like to see how much pollution's coming out of the sediments in your estuary or your lake or whatever it is. Dr. Jordan Beckler at Harbor Branch has developed this thing called the carousel, which actually sits on the bottom and uses some pretty high-performance sensors to understand how much ammonium and nitrate and other things are leaching out of the sediments. And he's getting ready through the FDEP Innovative Technology Grant to put it out for HAB mitigation in Lake O to understand better what's going on out there. We have the best, in my opinion, ocean optics group in the country is up the road at Harbor Branch. There's really, I don't think, another university or institute in this country that can compete with the people we have. Some of the things we're working on, we've been getting funded through ONR and a couple other agencies to look at imaging systems on CubeSats. The government's moving away from putting out these billion-dollar gigantic satellites. We're now putting out satellites like this. And we can put out hundreds of them on one rocket launch. They don't stay up as long as the other ones, but they're a lot cheaper. And you can get much better coverage of the coastal oceans or the land. So we're directly working on creating some of these CubeSats and the imaging systems to look at the ocean. I was involved in developing this. This was a holographic underwater microscope, specifically to look at harmful algal blooms in nature. Instead of having to take a sample and bring it back to the lab to use a microscope, this thing could image holographically in 3D space all the phytoplankton cells that are in there. That's funded. That's currently is being used on the West Coast to look at Karenia, red tide blooms. And it's something we just got from NSF, this next generation polarized scattering instrument. That was about $1 million grant. And it's to look at how light is scattered over the entire range. And this is important for satellites because what satellites see is the light that's scattered back from the sun. The sunlight goes down, it hits the ocean, it goes back. There's a lot of information in that backscattered light. So this is a next generation instrument to look at that light field. And the reason for that is we're heavily involved with NASA in what's called the PACE science team. PACE is probably going to be one of the last large satellites that NASA put up, I would guess. And it just got launched last year up at the Cape. It's called the Plankton Aerosol Cloud and Ocean Ecosystem, PACE, Earth Observing Satellite. It just went up. We're already getting data from it. Our scientists are already working on it, and they're actively working on how to interpret that data. These are actual data plots. That's Florida, and that red is that backscattered light, which with some algorithms we can tell is that algae, potentially what kind of algae is it? Is it sediment? What is this that's there? So, and as I said, we're using these ocean color products we get from this giant satellite to look at harmful algal blooms and other dynamics in the coastal ocean. So that's why we do these optical instruments so we can use other tools with them. So we do a lot of science, but like Florida Oceanographic, we do a lot of public outreach too. People have to know what you do. So it's really important that we do this. And if you remember from one of the first slides I showed, this was part of my strategic goals, was to increase what Harbor Branch did in this area. So we have an Ocean Discovery Visitor Center. It was renovated in 2016. It continually is updated. It's really good if you've never been there. We do have now a new boat tour. This was relaunched in 2023. Over 3,000 people have gone on a boat, and it's not just a tour of the lagoon. You actually get out there and have a real scientist telling you about what's in the water, and you get to see what's underwater They have video screens on all the seats, and they put out underwater drones so you can actually see beneath the lagoon. If you haven't done it, I highly recommend it. We do lecture programs like FOA. We have our own ocean science lecture series. And you who came here are probably bored out of your skull because you've heard this. We do Speakers Bureau too, where our scientists come out to you. We'll come to your organization. If you make a request to us, we'll send somebody out to you. Citizen science programs, Dolphin Sparta program. We do art and science contests to try to get kids, jazzed up about science. We do a lot of events and off-site exhibitions. This is hard to see, but this is a giant inflatable whale that we purchased that you can actually walk through and see its internal anatomy as well. So we took that to the South Florida Fair last year, and it did quite well with the audience. But again, it's something we can do if there's a big science festival or a community event. We can do these kind of things, and it gets people. They get to know us and they get excited about what we do. We also do a lot of public service. I do a lot of public service, and most of our scientists do too. And we do not get paid to do this stuff. We go out and gladly, give recommendations, give advice, try to help out the state or help out different organizations with science-based issues. As Zach said, I work on the Blue-Green Algal Task Force. I've been doing that for almost 5 years now. I am the ex-executive committee chair and the council chair for the Florida Institutes of Oceanography, which is the whole state university system works together for the Florida doing oceanographic research and assets. We have 3 boats. We run the Keys Marine Lab for research. So it's a cooperative effort between the universities. I'll probably be chair for the next year and a half, I think. I've worked on the Red Tide Innovative Technology Advisory Council. I sit on the management board of the IRL-NEP, board of directors of the Florida Ocean Alliance. I work with the South Florida Water Management District, and that's just me. Our scientists do a ton of this stuff too. And it's really critically important that we do this for everyone. The one thing people might have heard of, Florida was signed by the governor last year. We're going to have what's called the State Office of Ocean Economy. That office was going to be in commerce in the state. They decided to put it within the universities, and it's now housed at FAU. You can guess with a name like Ocean Economy, Harbor Branch is going to be a big part of this. So this is something I am actively involved in right now. We do a lot of K through 12 education. We're associated with the university, but we do all the way from kindergarten up to high school. We actually have a high school, a St. Lucie Charter High School on our campus. MOA, the Marine Oceanographic Academy, is on our campus. About 300 students per year, I believe, go through there. We do our floating classroom using our boat to give a lot of potentially disadvantaged kids from Boys and Girls Clubs in the area or different schools an experience out on the ocean in a lagoon. With the Indian River Land Trust, we work with the Junior Scientist Program, which is an immersive experience for kids. A lot of after-school education. We do summer camps at Harbor Branch. We also have state-approved resources for educators, so if any of you are teachers and want some STEM lesson plans, we have six curriculum bundles specifically on ocean-related education that we can make available. And as you would guess, we're a university. We do collegiate education. Something we just started in 2023, I did with the dean of the FAU College of Science, was to create ECOS. And this is the School of Environmental, Coastal, and Ocean Sustainability. And what we do is we have a lot of different programs at the university that work on environment, marine, some coastal, oceanographic. Harbor Branch isn't the only thing at FAU that does this kind of research. And we really need to put them together and leverage what we have because we don't have unlimited resources. The more we can, leverage it, the better. So this is a partnership between us. And all of these programs are now on one umbrella. Collegiate programs are under one umbrella called ECOS. So we have this educational pipeline that, we We almost have kids that have done all of this. They go to high school on our campus. They can go to our undergraduate programs like Semester by the Sea, and then they can go to graduate school and get a Master's of Science or a PhD. So we can get them from high school all the way to doctors as a pipeline. And what we really need to do is that K through 12 effort. It's really important that we get the younger generation interested in science, and wanting to go into it. We need people to do this work. There's a lot of work to be done. So one of the last things we want to talk about is philanthropic support. I told you this is, one of the things I also wanted to increase. Philanthropy, if you don't know what it is, it's just private financial support to nonprofits, institutes like FAU, like Harbor Branch. Now, the first thing I get asked when I tell people, hey, we need donations just like small, organizations do, why does a state-funded institute need private support? Doesn't the state give you all the money in the world? Aren't you great? No. Traditional funding sources for higher ed, and we get our operational support from the state and federal grants, they're under very growing budgetary limits. We haven't seen a real increase in our operational budget in over 10 years. Everything else has gone up. Inflation, all that, we have to deal with that. I have to do much less every year, or much more with much less money. And that's not going to change anytime soon. In fact, budget cuts are actually what are coming. We're seeing this at the federal level right now. Without private financial support, a lot of organizations are not going to do well, including us. And most people think, well, your faculty are paid by the state. They're fine. It's like, no, they're not. Most people don't realize research scientists are not tenured faculty. They're not paid to teach. They're paid to do research for you in the country. Our research faculty have to bring in 50% or more of their salary through research grants. They do not get paid by the state to do it. And this, if they're not competitive, they don't have a job. If they can't write grants and get it, they don't have a job. We have to lay them off. This is where philanthropy fills in and really helps. It allows these scientists to do the great work they do. How are we doing? This is our philanthropic funding over the last decade. It goes, I know the print is small, it goes from 2015 on the left side all the way up to this last year, 2024. Again, much like our research, yeah, it's going up. That's good. In the first few years before I really started, we were bringing in just under an average of $500K, $500,000. Now, in the last 3 or 4 years, we're averaging somewhere, double, triple that, 1.3-ish million. That's great. We need to do way better than that. I'm glad it's going up, but it's not nearly enough money. What are some recent gifts we've gotten that have really helped? I talked about this before, but the Builders Initiative Foundation, which is actually the Walton family, Walmart, they gave the $2.8 million for beginning to restore Queen Conch in the Bahamas to recreate that fishery. Because we got so much PR from that, we get a lot of organizations suddenly coming to give us money, large national organizations who are like, wow, that's great work you're doing. Success breeds success. So if you can get people to start giving, more people want to give. Recently, Wayne and Lucretia Weiner gave $1 million to ECOS, that school I talked about. $100,000 of that money is going to our Semester by the Sea program to keep it going, because without it, I have to close down that program. The state will not pay for that program. So it's funded by people like you. And we have a foundation, thankfully. It does help quite a bit. Not every college or unit at FAU has this, but they just, as I said earlier, they gave us $1 million for doing some of this seagrass research and nursery expansion, so it was pretty critical. If you want to help us, just like Zach said, I don't have a neat little thing for you to donate into, but you could scan that QR code. But at a minimum, I'm really interested. Everyone knows what we do. Connect with us. Join our mailing list in the back. Sign up for it. Follow us on Facebook and social media. Look at, we have a lot of stuff on the web that you can look at what we do. come visit us, take a tour, go on our boat. We do tram tours of the campus. You can see it up close and personal. And hey, if you got money, make a donation. We'll never turn it down. I'll name a building after you if you give enough. So I will end with this. My priorities in 2019 were what you see there, and I green check them all. I did, as you probably just saw, I did everything I set out to do. So where am I now? So in 2025, I finished 7 years. I got some more time. I'm going to continue the progress in all these areas. Obviously, it's critical to our core mission. I am really going to support the development of this Office of Ocean Economy for the state. I think this will be critical to us. I'm going to want to expand the Institute infrastructure and research capacity. That's only going to come through philanthropic support. The state's not going to give us more money to do it. And of course, to do that, I have to further our philanthropic support. But my overarching goal now is to really increase Harbor Branch's standing as a international leader in ocean science and technology. You have an amazing resource sitting right up the road. I mean, we are nationally known. We're somewhat internationally known. There's no reason why we can't be one of the best institutes in this country, because we're doing a lot of stuff at Harbor Branch. With that, I will take questions. Okay, I see one there.
Who are your competitors in this country? What other institutes compare with?
So the question was, who are our competitors in the country? I wouldn't necessarily, they are competitors in all sciences, but we have competitors within our own school campus. Sometimes professors want to go for the same grant, so they compete with each other. We're a pretty small group, but Woods Hole Institute, my old alma mater, Graduate School of Oceanography, URI, Scripps Institute of Oceanography in La Jolla, MBARI, the Marine Biological Lab out in Monterey, they were actually modeled after Harbor Branch. So when Ed Link and Seward Johnson created Harbor Branch, the Packard Foundation created MBARI on the West Coast in the model of Harbor Branch. So it's kind of flattery that they wanted to be us. They've now become way bigger than us because they got the Packard Foundation behind them, which is quite a bit of money. But we all work together as best we can. I know the leaders and almost know the leaders and know them well. Some of them are my friends at all these other institutes and universities around the country, and we help each other out whenever we can. I just got back from Rhode Island. I'm trying to start a joint research center with the University of Rhode Island Graduate School of Oceanography, so we can do some expanded DoD research and optical research to help them out, because they don't have the people we do. So but they have things we need, so we'll work together. Again, there's not a ton of money in oceanography. You'd think there would be, but we have to actually, as organizations, work together, and we advocate for each other a lot. Yep. Anything else?
Jim, from Zoom, how many researchers and staff members currently work at Harbor Branch?
That's a great question. I can't give you an exact number because it kind of changes. We have about 60 or 70 students at any one time. I think we have over 70 right now. But on any given day, there's about 240 faculty and staff at Harbor Branch. Over here.
Thanks. It was a very interesting presentation. And since your field is algae,
Mm-hmm.
we're all in Florida. I noticed that there were some distinct differences between the Gulf of America and
I'll never get used to that.
the Atlantic coast. So what are the triggers that are so different on both coasts for those different species to take place?
So the question was, why are there differences between the kind of algal blooms we see on the West Coast versus the East Coast? And in general, if you look at that, we tend to see a lot more here. One of the biggest things is, what do we have along the whole 140 miles of the East Coast? The Indian River Lagoon. What is all around the Indian River Lagoon? Heavy development. What does that lead to? Nutrient pollution. So you have this massive water body which doesn't have a lot of flushing with the ocean getting laden with nutrients, so it's a perfect, fertilized breeding ground for algae to explode. So that's probably the easiest answer to that. And a lot of the West Coast is undeveloped, kind of primitive shoreline. There are algal blooms over there, but red tide is kind of the major one they have to deal with. And of course, when Okeechobee's bad and they're dumping through the Caloosahatchee, they get blue-green algae out by Fort Myers and out where the Caloosahatchee dumps into the Gulf of America. I'm not hiding that well. Yeah, so the question was, do we have, I guess, support and infrastructure to handle, a lot of old septic systems? And it's not just old septic systems, it's old sewage treatment and some of the old sewer lines we have and all that. It's a great question. It's something we deal with whenever we have a task force meeting. I mean, I've had many people testify to us. The fact of the matter is, I've asked this question many times in a public forum to these various agencies. It's like, are we winning the race? We are, putting in money to fix septic systems and all that, but we're also developing incredibly quickly and putting in new septic systems. And even a perfectly functional septic system, brand new, meets spec and all that. I've heard and been told that at least 50% of the nitrogen of that still seeps into the water table. So that's if it's like perfect, never mind if it's failing. But if we're developing faster than we can actually mediate and put advanced treatment into the other ones, are we winning that race, or is it we're always going to be behind? A lot of people are moving to Florida. What is it, like 3,000 people a day or 1,000 families a day, something like that? And I've never got a clear answer on it. I suspect we're probably holding even right now, maybe, but progress is slow. This is built up over 50 years of development. It's going to take a while. And I do, on the task force and working with the district, I do get to see a lot of these reports and data analysis, and there are areas where you can see success, that it is working. There's other areas where it's going the other way. So it's really difficult just to give, yes, it's all great and it's all working. It's like, it depends on where you are and what's being done there.
Jim, You got the question. Are you worried about federal support?
Yes, I am worried about federal support. Today we're told, we're waiting for guidance. I can't really comment further than that, all federal funding was to freeze. Well, that's an issue because you can't just stop science, So I think we'll see clarification in the next few days, but I'm just waiting for guidance from the university and how we have to handle it. Do we have to lay people off? What do we do? I don't know. So we'll see. But I more expect, beyond that, we just see less money over the years being put into higher ed, and we see those budgets being cut back, and that's why philanthropy is important to Florida Oceanographic and us and everybody else that does this stuff. It's going to be our lifeblood, most likely. I'm getting back.
You say that it's safe to eat the fish out of the river?
So I was asked, is it safe to eat the fish out of the river? Yeah, we get asked this a lot. Most of the fish are transient. They come from the ocean. They're probably fine if they're out in the ocean. And the thing about a lot of algal toxins, this isn't always true, but in general, the toxins won't concentrate in the flesh, like the muscle, the part you tend to eat. Now, if you are making fish soup and putting the whole fish in there so that the organs are getting extracted, that I might not want to be part of because it will tend to concentrate, and shellfish, of course, filter algae, so you get a bad clam, you're not going to be liking life. I would have a hard time eating filter feeders or shellfish out of the lagoon. Only because I know way too much about the algae that are there. Sorry if someone here farms shellfish. Back behind you, right there.
If the water from Lake Okeechobee could be sent south rather than going to the coast, would that make your job much easier?
So the question was, if we sent more water south, would it make our jobs easier? It was, Yeah, right, exactly. And you know, traditionally, back in the day, before they did the the canals and channelization and all that, that's where most of it went. It headed down south. So we'd just be returning it back to how it used to be. It'd be great for the estuaries not to get so much fresh water in them. They are estuaries, so they are built to have some fresh water go into them. That's part of the thing. It's that saltwater, freshwater wedge. But not quite the inundation where you drop the salinity to zero and all the marine organisms die because they can't take fresh water. So the quick answer would be, yeah, it'd be good to kind of return it back to what it used to be. It wouldn't hurt. It'd be good for the people that live on both coasts that have to deal with this issue. But if the water is laden with nutrients and toxic algae, it ain't doing the Everglades any good either. So, I mean, yeah, it's out of sight, out of mind for you, maybe not for other people. So the fact that the answer is clean up the water so it's just water. I don't think that's too radical of an opinion.
This is kind of a naive question. Has anyone considered filtering the water that comes out of Lake Ocean? Is there such a thing?
No, I mean, the question is, can we filter the water that comes out? The fact of the matter is the scale of the problem is so big that's not an effective solution. You know, if you had a little pond in your backyard, not a problem. Lake Okeechobee is like a Great Lake. It's billions of gallons of water. We don't have anything like that in our technological arsenal that could handle something like that. It's not possible to do. Yep.
Is saltwater infiltration into groundwater affecting some of the stuff that we're doing?
So the question was asking about saltwater penetration, infiltration. So people down south we now have connectivity measurements. That's how you measure salt in fresh water. They have wells, and they are starting to see an increase in salt. Obviously, they're going to as the aquifer is drained or gets lower. And as sea level rises, that hydrostatic pressure is going to force salt water into our groundwater. That's just a fact of life. There's no way around that. But we are seeing increases. How long before it becomes a critical issue where we need desalination for our fresh water? I don't have a handle on. Might not be a bad thing to invest in the future. Yep.
Is there a population limit for Florida?
All right, you guys are asking really hard. The question is there a population limit for Florida? I say we've hit it. That's it, we're here, no one else. Yeah.
We're from Long Island.
Yep.
Connie Bay, estuary, if you will, and we have many oyster farms.
Yep.
They have clean water over a period of 14 years now. The red tide comes when the temperature gets too high,
Mm-hmm.
and they can't overcome. But these little supplicators dissipate 50 gallons of water per day. Each one of them to get eat the red tide. I eat oysters.
Yeah.
But it's so interesting how that has worked so well for us and others.
Yeah.
The other things that they're doing now, and they said, I don't think we do that here, is during the wintertime, the Cornell Cooperative has cats that they grow food for these covers, and then they let them out, they grow after about 18 months. But they're starting to do it in the wintertime.
Yeah.
Because it's better having lower temperatures, they propagate better rather than in the summertime when it's too hot. And they don't propagate.
Yeah.
Interesting stuff. I'm sure you're doing the same.
Yeah, so the question was, he was telling us about how they're using clam farming to basically clean water, because filter feeders, clams, oysters, mussels, things like that, they can filter amazing amounts of water. So if you have really healthy shellfish in an estuary or a lagoon or whatever, they can actually do a really good job cleaning up the water. They have to survive, and you can even eat them. Like they can feed on poisonous algae, but as long as you let them, wait in captivity and clean out, which they generally do anyway when they hold shellfish, they'll dissipate the toxin and they'll be safe to eat. you just, you're playing Russian roulette, depending on how long you want to wait. But, and and it happens. People get shellfish, paralytic shellfish poisoning all the time. It's not uncommon. But it's a good, what you're saying is exactly correct. When we want to do like seagrass restoration, we also want to restore oysters. We want to restore these natural things that used to be in the lagoon because they will keep it clean. But we have to have an environment that they can survive in. That's the trick. All right. Yep.
To add to that, won't the oysters die if there's not enough salinity?
Yep. So in the St. Lucie estuary, we monitor this, the district, St. John's, not St. John's, God, now I'm confusing on anyway, the water district that does St. Lucie. They monitor that all the time. They look at recruitment every year. But yes, they can take a short inundation of totally fresh water, but if they just get pulsed for like a week or two, yeah, you're gonna see mortality. I mean, they're marine organisms. They need salt as part of the way they've adapted to live. They can take a little bit, but not a ton. It's one of the reasons why the Corps of Engineers did go to pulsing releases. So instead of just opening the floodgates and letting it all go once, they would do a big release, but then pull back, wait a day or so, do another one. So at least the ocean would have a chance to get some salt back up into the estuary. And that seemed to work, sort of. So that there would be enough salt that the oysters wouldn't be destroyed by it. But that's exactly what happens. Yep.
Had a curriculum that was available to teachers.
Mhm.
Is it also available to homeschool parents?
Yeah. Oh, you can download it.
Oh.
Yeah, go on our website. You should be able to just download the activities directly. The question was, sorry, are our teaching teacher educational aids available to the public? Yes, you can download them. So they're state approved. Yep, way back there.
I am actually one of the oyster researchers at FAU, and I just wanted to verify your point. I was actually out there yesterday at Jarvis Park, and the salinity was measuring too.
There you go. But at least it measured something. Yeah, which is actually, I believe that's below the threshold of it starts to cause them a lot of stress. What is the threshold, 3 or 4? I forget what it is. Yeah, so that's just below. They're starting to get stressed out, so that's not good. Yep.
Can you stay on the fish population, a leveling out, if that's some critical situation? Because every time if you go into a buffet, you're taking a cruise, it seems like it's an unending supply of fish food.
All right, so the question is, and this, I'm sure you're talking about commercial fishing halls, and this is across the world. It's not just Florida. If you look at fishing statistics and fishing yields, I think, and you're a fisheries biologist, you should probably know this better than I do. They started to peak in the 90s, I believe, somewhere around there, and the yields are at saturation. All the fisheries we can exploit, we're pretty much exploiting to the levels that if we do any more, we're going to crash the fishery. So their yields are not going up. Now, that doesn't mean we're not taking stuff out of the ocean, but if you want to, our population is not static. The world is growing by billions, So there comes a point that, as you say, we're going to do one of two things. We're just going to have to replace that. If people want seafood, it's going to have to come from aquaculture, or we're going to decimate our fisheries. And they'll put so much pressure on them. They'll start crashing, which some fisheries have. I mean, that's not totally unheard of either. I don't know if you want to add a comment.
Looks like we have time for maybe one or two more questions here from the audience at the Blake before we wrap up.
Yep.
I'd like to go snorkeling for the scallop on the west coast of Florida. Those are filter foods.
Yep.
Are they safe for being eaten?
I mean, the question is, are shellfish on the West Coast, specifically scallops, safe to eat? I mean, if there was a red tide warning and it was, in that area, I probably wouldn't. I would wait a week or two till the thing was over. I think the state, boy, I'm not up on this anymore like I used to be when I was a real active harmful algal bloom researcher. The state does assay various shellfish around the state waters to see if they're detecting toxin in them. you probably could look and find out if there's any hits. But if there was a severe red tide going on the West Coast and you're eating from an area where the red tide is known to be occurring, I probably wouldn't, personally. Why risk it? Yeah. All right, one more, way in the back. Yep, you.
It seems like there's more manatees in the past couple of years. Does that mean the rivers
Well, they've at least, that large mortality event we had, 2 or 3 years ago now, has abated. So they're slowly will come back. I mean, it takes them a while to grow, but at least their numbers aren't being, decimated like they were that winter when they were starving. I have not seen any official assay numbers of how their numbers have rebounded. I'm sure they are. To what level, I honestly couldn't tell you, but at least we're not seeing that large-scale mortality anymore. So that's a good thing.
All right, folks. Well, if you could help me give Dr. Sullivan a big thank you for coming out tonight.
That's all you.
I just want to point out quickly, he was able to highlight some of the work that Harbor Branch scientists have been engaged in, but if you look back through the archive of presentations from this lecture series, you'll see a lot of names that were on the screen tonight. So we've had a number of Harbor Branch speakers present as part of the Coastal Lecture Series, and I encourage you to go back and look through that archives to see more about the work that they're engaged in. You could also check out a really wonderful archives from the Ocean Science Lecture Series that Harbor Branch runs. They have recordings dating back more than a decade on their website. So there's probably over 100 recorded presentations that you could watch on their website, and we have quite a few on ours as well. I hope all of you had a nice time tonight. I really want to fill the house next week. Dr. Gray's presentation is critical. He is a bird guy. He's going to talk about a lot of things, but he's well known for the work that he's done with birds that live in and around Lake Okeechobee, particularly the endangered snail kite. He's a wonderful speaker, and his topic is very timely. So I hope to see you all back next week, whether you join us here at the Blake or you join us on Zoom. Have a great night, everybody.